6:30 on a Tuesday morning. I don't know why I do this. I hope someday y'all appreciate this, or it's just not worth it. You know, they say it just takes one. I need more than one person. I need about 40 of y'all to be making straight A's for the work I put in on y'all. All right, this is number 7. You're supposed to solve this logarithmic equation, and it's not bad. It looks kind of intimidating, but maybe today, maybe tomorrow. But anyways, by the time you probably sit down and work on this, you were shown this property, a logarithm of some random base with some expression x equal to a logarithm of the same base. Notice these guys, they match, of y, then x equals y. And that's what I notice about this. There's a logarithm on each side, so I can just ignore them. Whatever's on the interior has to be the same. So this is a quadratic. We'll shift everything left, set it equal to 0, and then we'll try to factor it. Factors of 15 would be a 5 and a 3. To add to a -2, the 5 is negative. Now, we're going to have two x values here. X is either 5 or x is -3. And we're just going to look at it. We're going to decide which one if both of these work. There's a problem right here. If I plug a -3 in, I would have a log base 5. Twice the -3 is -6, plus 5 of -1. And it doesn't matter that it's base 5 or whatever, but the calculator is going to freak out. If I use change of base and do natural log of -1 over the natural log of 5, the calculator is probably going to tell me something along the lines of non-real. This is not real. That just won't work. This guy is extraneous. So make sure that you pick out the extraneous answer. This one is real. Because if you plug a 5 in, this makes a 15. Logarithms don't have a problem with a positive number. If you plug a 5 in here, this makes 15 positive, so it's good. So just be on the lookout for extraneous. Number 8 is about as simple as a logarithm as you can get. It's the understood 10 log. So I'm just going to put that base of 10 there. And again, your big deal on these things is log is bay. I just cannot write this morning. I need to wake up. Log is bay. So there's my base. There's my answer. And there's my exponent. So I'm going to be base 10. I'm going to raise it to the third power. And I'm going to equal 2x minus 2. And this is about as easy as it gets. 10 cubed, you ought to know. That's 1,000. So 1,000 is 2x minus 2. Add 2. 1,002 is 2x. Divide by 2. And x is 1,001. Ta-da! 9, we've got something involving e. And you can convert it to a natural log or you can ln both sides. It's really up to you. But first thing we got to do is we got to isolate this thing right here. This has to be isolated. Okay? Let's make this a negative so it's more similar to the original problem. So I'm going to add my 4. 4e to the negative 0.25x is now 18. I'm going to divide by 4. A couple of y'all, and I can think your names right now, will want to write that as a decimal. Just leave it as a fraction. But what do I know? E to the negative 0.25x is 9/2 when you reduce. And if I was doing this problem, you could do log is bay, but I would actually just ln both sides. Notice it wants the answer in exact form. So pay attention to that. Exponents get moved to the front. The natural log of e is 1. It's what she is. So she's gone. All right, because she's a 1. Negative 0.25x times 1 is still negative 0.25x. Divide out your negative quarter here. And I'm going to rewrite that. Because that's what it is, right? And you're looking at this, which is a pretty good answer. But you're going to have to do better than that. To fix that, you multiply by 4 over negative 1. Or, sorry, negative 4 over 1. And you're going to get negative 4 natural logs of 9 halves. And now it's not a fraction. You're still going to have to do better than that. Division is subtraction. There is the answer as pretty as she gets. That's as pretty as she gets. Now, I'd probably make this multiple choice. So if you can't get down this far, what you can do is you can take what you had. If you got this far, you could type natural log of 9 over 2 divided by, even if you like decimals, you get that little decimal right there. And you could just go through here and you could type in answer choices and see which one matches. Maybe eventually you'll understand that what's going on here. Ta-da! They're the same thing, kids. They are. One of them just looks prettier than the other. There's such a thing as formal mathematics, where you try to make the answer just look as beautiful as possible. And that is considered beautiful. That is considered fugly. Okay? Number 10, solve log base 3 of 2x minus 5. Again, this needs to disappear. Don't care about your decimal. Give your answer in exact form. So here's my similar example. Log base 4 of 3x minus 7 is 5. There's your base, there's your answer, there's your exponent. So 4 gets raised to the 5th, and it must be 3x minus 7. Oh, this is an easy one. 4 to the 5th, if you don't know it, it's 1024, but you can push buttons. 1024. Try and memorize that. Add 7. That'll get you to 1031. And then divide by 3. I'd be shocked if that's simplified. And it doesn't. So there she is. What is the domain? So I was hinting at this when I did number 7, and you'll have at least one slide of notes about this by the time you take a test. That's got to be sufficient. So if you have the log for any log with some argument inside of it, that's argument, the argument must be more than 0. That comes from vertical asymptotes on graphs and things like that. You just can't cross that vertical asymptote. So here's my argument. Plain and simple. It has to be more than 0. That's really how hard domain of a logarithm is. 12x is now greater than, what, 4? Divide out that 12 and x is greater than 1/3. I don't know how I'd leave this, but if I like my set builder notation, all values of x such that x is greater than 1/3, or if I like interval notation, 1/3 to infinity. Be fluent in both. The function f of x is the natural log of x minus 5 is transformed into g of x equals the natural log of x plus 3 minus 7. Describe the transformations that take place, and here's my similar example. X plus 3 plus 1 becomes x plus 8 minus 12. So the deal is always whatever happens with x is opposite of what you think. So always opposite with x. So when you look at it, you think you added 5 to x. You did not add 5 to x. You did not shift right 5. You shifted left. So there's that transformation. This transformation is very simple. It's a horizontal shift left 5. And we went from +1 to -12. And this one you can trust. We simply went down 11 units. Because, sorry, not 11, 13. The vertical shift down 13. Because we lost 13 units. All right, 13, the old pesticide problem. Pesticide kills 61% of all bugs every 25 minutes. Determine the hourly kill rate. Similar question. It kills 45% every 10 minutes. Determine the hourly rate. So if I was, by the way, when I set this thing up, I'm thinking about exponential decay, principal times 1 minus r to the t over, in this case, 10, because it's every 10 minutes. I do 1 minus 0.45. I'll bring that 10th in. Sorry. Ignore me on that. This says every 10 minutes. I'll plug in my rate, which is 0.45. And if I want to make it an hourly, I could feed this thing 20, 30 minutes. But if I wanted to make it an hourly deal, I would throw it at 60. So I take my t over 10, and I multiply it by a 60. 1 minus 0.45 is 0.55. This will give me 6t. And now I can move part of that in. There's other ways of doing this one too, by the way. I got this decimal 0.0277. Now, pay attention to the lineup. That is in the same exact spot as 1 minus r. So 1 minus r is 0.0277. Put your r over here and subtract 0.02771. And there's your hourly kill rate. Your hourly rate is about 97.23%. That's how you do it. Yeah, that's about as much as I'm going to do on that one. Certain rumor spreads around town at a rate of 38% every 15 minutes. Similar is 43% every 6. It says write at least 2 different equations that model this rumor spread. So let's just start off with the default one. The default one is where we plug into, and this is growing, right? At rumor spreads, this is growth. Would be that the amount after time is the principal 2, because we actually don't know that, just the principal, times 1 plus 0.43 to the t over 6. And that thing will clean up to be 1.43 to the t over 6. There's one of them. All right, you need 2. The other one's real simple. Move that 1/6 in. T over 6, move that 1/6 in. And evaluate what 1.43 or what the 6th root of 1.43 is. There you go. Principal times the 4th decimal, 1.0614. Now to the t. There's your 2 equations. It says at least 2. I guess there's probably a third one somewhere floating around. I guess you can convert it into hours if you wanted to. Raise this to the 60th power and you'd have an hourly equation. 15, we got another solve a logarithm. G is a free response. This will be an exact form answer. So we have a log base 4 of 2x squared plus x plus 49 is 3. Do your whole log is bay idea. You get a base of 4. So 4 to the third power is equal to this. 2x squared plus x plus 49. 4 cubed, been 64 my entire life. It will be your entire life. Subtract 64. I think you get a negative 15. Yeah, you do. And factor. Takes a 2x and an x to create 2x squared. Factors of 15 would be 5 and 3, but placement matters. That'll make a 6x and that'll make a 5x. And the goal is add to a positive x, so I need this to be positive and that to be negative. If you use your cover-up technique, you get that x is a 5/2 or x is a negative 3. And you need to check for extraneous. Kind of go back up to the idea right there. For any log with an argument, the argument has to be more than 0. So I'm just going to take these answers, put them in x, and I'm going to plug them into that logarithm to see if they actually make sense. That one's fine. It's a real answer. The other one was 5/2, which I know is going to work. So these are both real. You know, and I'm doing stuff like this, by the way, because I teach algebra. You got to know the algebra. I could have also just, it's test day and like I have testing anxiety or whatever, because y'all are weird, I can type this in a calculator. Natural log of 2x squared plus x plus 49, sitting pretty over the natural log of 4. That's on the left. That's change of base formula, which we've talked about. Put a 3 on the right. Zoom 6 it. You'll probably see both answers on a zoom 6 on this one. And they are. There's one there and one there. Second trace 5. Enter, enter, enter. 2.5. By God, that's 5/2. It is. Second trace 5. Get close. Enter, enter, enter. Negative 3. Oh, it's still there. It is. Pause that video so I don't lose anything. And I'll be right back in a minute. Yay.